we're built on Substrate, and we've been working to try to provide verifiable credentials and DIDs. What we say, these two things together create a digital identity. So I'll go over a little bit what they are, and we can just break it down. So first off, this is what a decentralized identifier looks like. So you can see on the left-hand side, you can see the identifier itself. It's this hex string followed with a, before it has a prefix, which is did and then KILT. That's our method. So again, with the method, you can see we have this universal resolver. This is basically, you can resolve, ooh, I guess my mouse does this. Yeah, so you can see this here, and this will resolve the document. So the document is the JSON on the right. Basically, this is what we store on chain. It's completely public. And you can see here, it holds a number of cryptographic material, some service endpoints. You can see here, I've attached my email address to this. And you can also find something we've done for more human readability, and that is a Web3 name. So you can see here, the other identifier is called the counselor with one L. I'm actually one of the council members of the KILT protocol. So again, you can use this to look at the my document itself, and you can see which accounts I've linked. So yeah. So and again, we use this identifier or DID in order to provide one tool towards the digital identity. And with the next, we'll talk about what separates the DID from account. So again, if you do have any questions, feel free to ask them in the chat. We have people, my colleague Tina will answer them, so please, yeah. So why a DID is not the same as an account. So usually, in general, we say that accounts can be used as some form of identity. Well, we wanted to separate the two, and we think it's much better in this way. And we can imagine that the DID itself provides a fatter identity hub for the blockchain. And so you can see here on the screen what the two differences, or at least some parts of it that we like to highlight. So accounts, you know, they hold balances, they pay fees, they do voting on-chain governance. However, they have a fixed private key. Again, this can be somewhat of an issue. If your key gets compromised, there's no way for you to rotate them. And so this is what a DID offers. So a DID can hold credentials, they do key rotation, and they can be linked to multiple accounts. So again, you can imagine that when you go with your identity, for example, going to some store, you're not going to show your account balance with your identity. So if you show your, for example, your driver's license to buy some alcohol, you're not going to have your balance there. If we didn't separate the two, you would see your balance there. So that's not something that you want to show to anyone. So yeah. Now, going on to the idea of the credentials themselves. So again, I touched upon this at the beginning. Part of the digital identity, we use decentralized identifiers, which are DIDs, and then we have verifiable credentials. Again, this is the following JSON on the right is part of what a claim structure looks like. So we call these claim types, so C types. And we anchor the hash of this object. So you can see here, this hash is basically the representation of this C type. So we hash all of the properties here, and then we get this. And this is quite an important step. It allows for like standardization and for people to have specific credentials. And yeah, this structure is something that we'll be using in the workshop. So not the specific one. Anyone can create the C type. That's also something I should identify, that people generally think that we are the only ones that issue them, but anyone who has a DID and they have the certain keys, you can then issue or create a C type and then anchor that on chain. So I think it's really important, again, to identify that a claim type is just giving the claim its structure, and so that when we do share a credential, we differences or at least what the claim structure's typing is, so that you can make sure that you can conform to that and have some sort of proving on it. So again, this is actually what the credentials look like. So here you have a private and public credential. So one of the things that you can see here on the right is this private credential. I threw this together. So again, some of this information might not be true, except for the contents. My name is Dudley, and I am 29, and that is my email address for work. And you can see here within the claim structure itself, this is basically what the user holds on to. So yeah, so I'll answer your question in a second, Richard. But yeah, so this private credential is held by any claimer or user. So again, this is going to be in my wallet and under my control, so I can showcase people whenever I choose to, and it's not going to be on the chain. The only information that is stored on the chain is the root hash, and that's the secondary thing. Yeah. And then on the right-hand side, you can see a public credential. So basically, a public credential is given to some form of asset DIDs. I won't touch on these, but it's good to know that to identify objects that are, or subjects that are unable to sign, you can see here that this is actually the item that is stored on chain, right? And this can give you all the information that is defined about this specific asset. And when I mean asset, it can be an NFT, and in this example, it is an NFT. And then you can define it with a C type, and then whatever claims that you make about it. So yeah, I won't go into too much detail about hashing algorithms and the hashing that we do here, but for the private credentials, we basically allow for selective disclosure, allowing you to disclose certain attributes about the content. So for example, my name, age, and email. When I want to verify something or provide my credential to someone, I don't have to show all of the attributes here, like the age or the name. So the thing that the individual or verifier might want is just the age, and I can just hide my name and my email address and just provide the age. So yeah, so that's just kind of like a brief overview about what different credentials we have and what they look like, so that you have a bit more of a feel and flavor to them. So Richard, just to answer your question, yes, we do have a C-types library of sorts. So C-types, if you to generate the C-type again, so for example, this C-type on the right, you can see the different properties, attributes, and the title. If you were to regenerate this, you would get the same hash out of it, and the chain will throw back a response if there is already a C-type on chain with the same structure. So we'll go through this a little bit on the workshop itself, and we can have a look and see how to verify that if it is on chain, to just avoid recreating it. But you need the structure in order to build it. So yeah, and if you know the block number and the C-type hash, you can actually fetch it, because we use one of the little features in Polkadot, and that is remarks. So we just leave a remark there with the actual C-type structure, and that allows us to have a reference point of what it looks like. So yeah, again, we'll go over the C-types whilst we're doing it. And here, this is the important part for this following workshop, is what we're trying to achieve at the end of the day, is the attestation. So for example, you have a C-type, you have and you have a claim that you want to make about someone, and in order to create a proof, this is basically the proof that's on chain. And so we can break down what's actually here on the page right now. So the C-type hash, again, just explicitly just saying, that's the hash of the C-type that's being anchored on chain, and you can use that as to know what the structure of the claim has been made. Then we have the attester, so that's the person who issues the credential. Those individuals are basically stating that this information is the proof that they've done the credential, and if they've attested to some credential. Again, just for reference, I did miss this out on this slide, but you can see here the root hash. This is where we link the two. So the attestation between the two. So you'll see this here. And again, I will leave the authorized ID out for now, but it's yeah. And then the revoked. So again, we can flag if the credential itself has been revoked. For example, you may have a driver's license, and for whatever reasons, your driver's license expires, or you do something, you can actually revoke this on chain, and then that flag will set to true. So allowing us to have revocation on chain is a very important step. And yeah, and here you can see a deposit. Since we store the attestation on chain, we use deposits in order to anchor this on chain for storage use. Again, it's out of the scope of this conversation for today. So again, it's yeah, I'm trying to get through this because we've only got 50 minutes to try and get some coding in. So yeah, again, we'll look at this a little bit more in detail, but this is kind of like what we're trying to achieve at the end of this workshop, this piece of code. Okay, I'll go through this quickly because I wanted to finish this within 10 minutes. I'm a little bit over time. Anyway, so usually within the KILT protocol's workflow, we have three actors: the claimer, the attester, and the verifier. So you can see from number one, the claimer wants to have some form of claim attested. So that means that they want some proof that this claim is true. So the attester does some due diligence. They check the claim itself, and in doing so, they create a transaction. This transaction here is made up of different palettes. You know, the attestation, DIDs, C types, and delegations, things I've mentioned previously. And then they write this transaction on chain, and that's the attestation. So that if the attester states that this credential is true, they will anchor it to the chain itself. And once they do this, they will send a response back to the claimer. You can see on number 5 that, hey, this credential is valid and you can use it. So you can see this interaction here from the claimer to verifier, that the claimer wants to go to the bar. He wants to show their ID. And in doing so, they provide the presentation of this credential. They sign it, and then this verifier checks the chain itself, and they do their own due diligence by making sure that they trust the attester and that they accept this specific credential. And in doing so, the verifier states to the claimant, yes, you are eligible to come in. And in doing so, the claimant can go to the bar, and so forth. Yeah. Okay, is there any questions for this part? Otherwise, then what we can do is we can start doing the coding itself, and we can go through it. So with this project, I will be using the KILT distillery. It's a little on-ramp tool. So you just, if you are going to code along with me, you can use this in order to join in. I'll leave the link in the description, but if you can, yeah, jump to it, that's not a problem. Again, it's going to be recorded, so thanks for watching the little presentation. I put in some important links, and then here I also put some helpful links in case this is shared. I also included the Polkadot Hackathon attestation demo. This is a full repo. This will basically, by the end of what I'm trying to achieve, will be the full demo. Again, it's a demo. It should show the attestation process. Again, also the links for documentation and Discord as such. So yeah, we can get started. So just to answer your question, can there be a fourth party who will approach the VATs? Attester, yeah, will approach the attester on the claimant's behalf. So like a proxy almost, Richard. I mean, if you want to make a claim about an entity, so for example, a DID themselves doesn't have to be an individual person. We just use them as an idea for like a, you know, an identity itself. But yeah, you could definitely attest that on behalf of something else. What that use case is, I don't know. Again, I don't see why you couldn't make that assumption, but then the claimer must sign this information. So yeah, I'm not sure if that's going to be a problem, because the claimer must sign it. So if you can get the signature from the claimer, then I guess you could. But again, I'm not sure whether that would be the use case. Maybe whilst I start. So yeah, so I threw in this tiny URL. This is for the KILT distillery. This will get you to the GitHub. You know, I can showcase a little bit what that says. Yeah, if I go to GitHub and then KILT protocol, so you can have a little look. If it the screen's too small, I will enlarge it. So yeah, it'll take you to the distillery. You have to clone it, SSH or HTTP into it, clone it. And once you clone it, you know, just npm install and yarn install. Maybe some pretext before that. And this will be in JavaScript and TypeScript, so and it will be a React-based project. But yeah, so what you can do is just clone this and then start the npm yarn run start. So yeah, so now let's just get going. So again, if it's too small, I'll just enlarge it. So yeah, I've already pre-installed it, but you know, you might just want to just install it. I'll be using yarn, so yarn run, and I've already done this, so I'll just run yarn start. You might, if you want me to slow down or if you want me to explain some things, that's not a problem. But yeah, so I'm just running the script. So the script essentially generates a project along with some test accounts so that you can begin some form of little project like this. So again, I'm just going to choose the first one. And what I'm going to do is create this Next.js credential login. It is using Next.js, so there is some, it's not just in Express. So, or yeah, you might need to know a little bit more about it, but yeah. So I'm just going to create a user or a name for this. I'll just call it Polkadot Hackathon. Usually I'll add the dots in front of it and the slash because it actually generates the in the directory. Yeah. Yes, it was yarn run start. Yeah. Yeah. So right now I'm just gonna begin the project. So more or less, I just gave it a name, and then afterwards I'm gonna give it. So we're gonna be using JSON Web Tokens. I'm gonna basically state it for a day. So JSON Web Tokens are great here. Again, I'm going to renew it. It's just not so important. So what I'm doing here is I'm just selecting a network. I'm going to choose Peregrine. Peregrine's our test network. I would highly recommend doing that network for any sort of demoing or trialing stuff. Yeah, we have a faucet for the test network. You can take non-valued tokens to try. And what I'm going to do is just generate a mnemonic. A mnemonic will then generate a DAD and then force to begin the testing. So here, again, this is out of the scope of this this workshop, but I'm just going to create a local host for this so that we can log into this. So again, the script is just going to go through. It's going to check to see if I have balance. If I don't have balance, it's going to send me to the faucet that I just pre-mentioned. So I'm just going to click on it. You can just highlight it and do so. And in the background of the script, it basically creates a DID. This is just to on-ramp and allow people to set up a project pretty fast. Again, I'm going through it pretty quickly, mostly because I want to try to get to the actual coding part. Again, it's ambitious, but yeah, so I'm just waiting to log in once I've, not log in, once I'm to generate the funds here. Yeah, okay. I will. Okay. Wait, no, in here. I will send the link for the Sporon. Did you? Yes, I picked Peregrine Network. That's what I picked. So I'm adding the Sporin extension because you're going to have to use it, unfortunately. I know there's a lot of requirements here, but again, this just helps things out. So I sent this link. So basically, it's a wallet, and it would be needed in order to interact with this demo, unfortunately. So again, you will have to follow the instructions there. I can showcase that in a second. So here, the CLI or the command line is going to ask me to generate some claims. So in the background, it just generated the DID and so forth. So yes, I'm just going to set up an extra account basically that allows me to do basically test some stuff. Again, it's a separate account, so it's going to request new funds, but you can't really see that here. So again, it's requested some new funds here. So I'm just going to request those. And it will be recorded, so it does give you a chance to slow down and take in your own pace and try to, if you want to finish it at the end of it, but again, trying to get everything in as we can. So yeah. So yeah, where can we find the recording? That's a question that I think the Angel Hack would have to let you know. Unfortunately, I don't know where they're gonna post this recording. So again, whilst I wait for this, I think this is gonna maybe take some time, unfortunately, because I think if there's a few people doing it at once, the faucet's just going to be very angry. In the meantime, what I can do is just go through the instructions for the Sporin extension, because you're going to need this for this project, unfortunately. So again, once the setup's happened, you only need to do it once, and then you can start building it. So the Sporin extension is the wallet that we use. You have to clone the repository. So you can either do the same thing again with GitHub. You can clone it, and I have a repository here already. And again, I would just, once I'm inside, this is the extension, Sporin extension, you can see here, the desktop workspace, and then Sporin extensions. I'll just yarn and install it again. Yeah. I think I need to refresh. Maybe the faucet is playing. Yeah, I'm getting some issues there. So what I do is I will send the money to myself. So bear with me. Okay, yeah. So yeah, so I have to send again real time. Sometimes this stuff happens. I have to run dev to begin the extension. So again, yarn run dev. And then I've opened up a second terminal. So you can see here, this is my one for my extension, and then one for another extension, because then once you've done this, you would have to yarn run open Chrome, and I will open Chrome. It's, yeah. So, okay. Make my life easier. I'll just send some tokens to myself just to bypass this, because I think a lot of people are working on it. Ooh, I think I'm lagging. Yeah, I think you're address it. Thank you. One sec. I'm just gonna send my address to my colleague. Oh no, we're speaking already. Yep. Yeah. So he's just going to send me some tokens. Again, it's the faucet's problem here is that it knows that I just requested funds, and it's just complaining that I have already requested funds. Yeah. No. Yeah. It doesn't want me to have funds at the moment. So whilst we wait for my colleague to send it, I think it should take a couple of seconds. And just going back, I know I'm switching screens a lot. Again, you can see Sparrow extension here, and then you can see yarn run dev. And then whilst we wait, once I've done this, you see this nice little script that's come through. I have then gone into a new terminal. This new terminal just runs another script called yarn run open Chrome and launches Chrome itself. Again, you can see here that it's opened up for me and so forth. Once I wait, how many tokens does it create to a DoD? Less than one to create one. However, the deposit is 2 tokens, Richard. So a deposit has to be made. So the deposit basically is permanent or until you remove it. So at least you need at least 2 tokens deposit, and then at least less than half a KILT to create it. So again, I am waiting for a response, but this it's not happening. Come on. Okay, all right, it's past it now. Thank you, Tino, for sending it. Yeah, you can see here, this is now the part of the script of the distillery. It's just going to create some claims that, again, this is just, you can add whatever you want here. This is just for testing. Again, it's not super important. Yeah, just randomly typing stuff. This is not super important. It's just to be used in the testing. So again, they're just being self-attested. It's just not necessary for what the content is inside of them. It might be in the future that you want to have these specifically as a credential for a claim, but that's also something that can be easily done with the script. You can just start it again and just create your own claims again within this. But yeah. Yeah, I have a Cedric. I have a repository. So again, it's all open source, so you can see what's actually being done there. It usually doesn't take this long. I think there's just people using it. So yeah. So I can send the repository afterwards, so that you can have a look. Connor, yes, I do. It should work. Unless you haven't installed it, maybe. So again, with this Sparrow extensions you should have here, if you yarn and then yarn run dev, it should build it in development mode. And again, yeah. Okay. So once the script is finished running, okay, so it's this one. Once the script is finished running, you'll see here, this is the desktop workspace and then the repository that we were just in for the script. And you can see there's one called Polkadot Hackathon, if I can find it. So if I just, there it is. And then I can see, I can go into that. So Polkadot Hackathon. And you can see this, yeah, thanks. I did probably, I did. Okay, Connor. Yeah, I'm not sure about Windows 11. It might have a problem, but yeah. Again, it's gonna be much more. I don't know how to do it on Windows, unfortunately. But yeah. So here, I'm just gonna look at the. Yeah, sorry. You can see here within this project that we just created, we get a React project. It's a little React TypeScript project, and you can see here scripts, you know, for dev and then start. So we'll be running this in dev mode. So it should already be, okay, so you need to install the packages. If you're using Yarn, then use Yarn. If you're using NPM, you can also use NPM. Again, now we just wait for the installing process. It's going to take some time. So what we'll be doing within this package is we'll basically be using its current structure. So it allows us to do some form of communication with the wallet itself. But what we really want to do is look at how like to integrate an attestation workflow. And there's going to be some core components. So more or less, we'll be working with creating the front end and the back end part to do more of the cryptographic well, signings and stuff. So yeah. So now that's done this, you should be able to just with Yarn run dev, and then doing so, you can get a little project going, and it's loading. So again, you can take the localhost URL, what we specified in the step of the distillery, and I'll just go and get there. So again, if everything's gone smoothly, if you've had a little bit of luck and watching me do this, you should get a page called credential logins. Again, you'll need to connect your wallet. The problem is it's likely you don't have an identity in the wallet, and so you can see here I just opened the wallet. I don't have an identity, but you can see in here that we have two accounts. We have the account assets, and then you have the claimer credentials. So you actually want the claimer credentials. So again, you can, oh, I think I am in the wrong, yeah. Claimer, and then you want the environment variable here. Again, this is a test account, so you can take this account if you want. It's not going to have any real funds on it, but you can use it. It's also fine. Again, I'll just take this mnemonic. So this is what the mnemonic is that we use to generate the DID within the script. And so I can add this now to the sporon. So the sporon basically wants an identity. So we can give it one, so import an identity with a pre-existing phrase. That's what I clicked. And you can see here, I'm just copy and pasting it. So you can copy and paste into this to just do this. And then what I'm doing is I'm generating a password. It's super secret. Please don't tell anyone. It's called password 1 2 3 4 5 6 7 8 9 exclamation mark. Okay. So once you have this, you can see that you have some test tokens. Again, if the script worked for you and so forth, you can, not necessarily super necessary for this demo, but what we want is at least some credentials. Again, you can't, okay, so bear with me. I'm just going to import them. I am slowly, yeah. Where is it? Distillery. Again, this is going to be different for everyone, but I'm just trying to get where the credentials are, where the credentials of this specific mnemonic were kept. This is the folder. I know where it is. It's underneath claimer credentials. So again, might look different for you, but once you've imported them, you should get like green tick marks, and that means that you've got the right credential for the right account. So now if I went to this Sporum page, you can see now that I have a number of imported credentials from Peregrine, which is our test network. It has no real value. And then the self-attested is just a social KYC. So basically, just these test credentials. And so now, if I do things correctly, we should be able to log in. Okay, it's just requesting that I have authorized this application. I say yes. And then I can log into this again. And I'm just passing it just so we can get through. You can imagine this is a very similar process for logging in and authenticating the user. So this might be different in someone else's flow and so forth. But now you're actually able to access the page. And so once you access the page, now we can actually look at some coding. So I normally, this is how I work. I usually have open up my project. So again, I'm going to go back to the directory where the Polkadot Hackathon project is that we generated, and we can have a look at like the project itself. Is there any questions? Okay, no questions at the moment. Again, my suggestion is any editor that you can use for this. So just you can open it up and you get your editor. Bear with me. And what I normally do, this is how I work. I usually try to put my web browser next to it so I can see what's happening on screen, and then I can also check here on the editor. I'll make it bigger and so forth. Okay. I'll open up a terminal. I usually like to see my process coming through. So again, in case I want to, I will close this. So now, I'll use the terminal in here so I can see what's actually happening. Yeah. Okay. So yeah, I know it's a bit of a setup, but I guess we're here now. We've got this far. Let's actually talk about what we can implement. So realistically, what we want. I think it just refreshed the page. Yes, it did. Okay. Yeah. So what we want to do is we want to add an attestation workflow, and for this attestation workflow, it knows that I had a cookie before, so it's trying to log me in, but I'm currently not logged in, so I just kill the session. I didn't kill the session, so yeah. Okay. And so now what we kind of do is we want to look at like trying to add an attestation workflow. And one of the important things is that what I previously mentioned about these claimer and the attester roles is that we want to be both in the claimer and attester side. And so what we want to do is basically create a new page. This page is going to look very similar to what some form a structure for the application to type in some input, right? So again, we're going to want some sort of function that's just going to be called like get claimer data, and this is just going to route. So again, we're going to be using some Next.js tools for this. So there's a router. Again, we're just going to create a path here and just call it like, again, the way this folder structure is set is that we have to, inside pages, we're going to have to add a place. So claimer and claimer. So again, what I'm going to do is create this little push, and this will take us to a new route. I have to define this route in the folder structure, so in the pages here. So I'm just going to call this, it has to match the same name that you just entered. And again, I'm just going to create this, that's called claimer.tsx. Again, if I give it some form of information, you know, I'm just going to kind of just do like a little function. Again, we do this basically, we want to export it. We want to make this a default, and then this function is just called claimer. Again, this is going to be using TypeScript. I hope it's going to help out a little bit. So yeah. So I want to use some of the existing elements here. I don't really want to have to redo everything. So there is a sequence page that we can just sort of borrow some stuff from. So again, we can just borrow some of this structure so we can actually have a nice uniform page. So again, we're going to be dumping a lot of stuff. So don't worry, a lot of stuff is going to be cut from this, and we'll just reuse it. So again, we're not going to use this. So again, the card, and so forth. So now I'm going to switch back into the index file so that we can actually see if we can actually get to this page, if this worked. So yeah, again, we can just copy the button. So again, copied the button and so forth. We want to call this something like get claimer data. And data. So again, just fetching this, and if things go right, it's not letting me through because I'm not authorized. I remember the session dropped previously, so just gonna wait for the session. Okay. So I'm just logging in again. I have to start a new session. Sorry about that. It's just I killed the server, so I have to start again. Okay, there you go. You can see I'm logged in again, and now hopefully, oh, the button worked. Okay, you can see the button worked. That's great. We like the button. So yeah, so kind of what we want is like this little button so that people can have some form of inputs. Usually, I want to keep things a little bit like when we're thinking of like what a C type looks like, we can define it here. So first off, I'll import KILT. So import as KILT. Oh, I'll do small lowercase from SDK. So okay, yeah, maybe just to go over the SDK. So we have KILT protocol SDK. It's inside the packages here, so you can have a look. Yeah. So once I'm in the claimer, I can use this to import it. So again, I kind of want to define the C type that I want to use. So going back to the structure itself. So in the SDK, we have a package or called core, and inside the core we have the C types. This allows us to do what we need to set the structure of the properties of a specific C type. So I'm going to give it a name. I'm just going to call it name. Not super creative. It's more about like just showcasing what we can do. I'm going to define some properties. Again, it's annoyingly remove the hover. Name. And again, this is the structure. We have documentation pages that will you can see here that will identify this. So I know first name, and then I need to define a type. That type is going to be a string element. So again, string, and you can see here, I'm going to choose second name as well because why not? And then I have a type, and I can also call this string again, and that in itself is a C type. So again, if we console log this out now, so I can just do does it here, C type. You can see here, it generates a C type. So I think Richard, you previously asked if how do you prevent people from doing two ones? C types is the same. You can see here, I have this ID, and that's something that we can query the chain to see if it's on chain. So we can have a look at that in a minute and go from there. So yeah. So now that we have this C-type structure, we can then define the properties that we want to use. So again, if you're not familiar with React, you might find this a little bit confusing, but this is something that we're going to be using is hooks. So I'm going to create these sets of hooks to be able to do some data entry or for the user. So I'm going to define this as a state object or state. So use state. This is a hook in React, and I need to import it, obviously. So I'll just import it into React. Again, I can copy this object. So maybe I just, I have hotkeys, instead of doing that, I can do this. I will then set it to second name. So again, second name. So now we have this. We can also check to see if we have this working. So again, we can say first name and then second name. What is the name? And if I remove the C type from this, you can also see that there's no names because it's not defined yet. So yeah, so let's define them. So within the card object, within the page, we want to basically create some input fields. So again, it's not super like important, but maybe we can define at the top of this card for beauty sakes. One page. And then we're going to define an input field here. I don't need all of this. So again, I'll define a value. We know what value we want. We want so for example, this is going to be, I guess, the first name. So I just say, okay, this is the first name, and then here. And then I can call this based upon the state here, first name. And then I want to define what type it's going to be. Again, we know it's going to be a string, so we want to just call it text again. And then when we want to do a listener, basically listening to what's actually being changed on the page. So again, we can define this with onChange. And whenever a change happens within this input, we're going to set this as the first name. So again, using the React hooks to set this makes it much easier. And then we're going to target this value that we call. So this is the value. So again, it's a little bit like, well, it's using React. So you can see here, I'll just format it. I'll unformat it. Okay, so you can see here all of this. Again, we can do the same thing for the second name. So now if I type something, I guess it's complaining because this is the second name. So if I change this to the second name, and then this is also second name. Okay, there we go. So you can see now we have the names, which is great. So I'll format it just to make it look neater on the page. Maybe zoom out a little bit. Yeah. Okie dokie. Yes. So now we kind of have like the basic entry into what we want to do. We kind of want to send this to the backend because the backend is actually going to handle the process. But what we can do in the front end is actually create the handler. So basically handling the claimer data. So we can create a little asynchronous function here for the project. So I guess we call it handle claimer data. We want to make sure that there's actually information, so it's not just being sent randomly. So I just put an if statement here for just ease of use, just to say return. Again, not super pretty. It's yeah. Again, we also only want people to access this if there's a user. If there isn't, just throw an error. No, I just throw new error. No user found. Again, they shouldn't be able to get this far, but if they do, I don't know how. Maybe some magic. But yeah, just yeah. So now, once we have the first and second name, we can actually define the C types claim. So again, I want to call KILT C type. I want this specific structure, but I want to define the claim. So again, we have in our we can call this a claim, and we can define this from our KILT.SDK. And you can see here the list of different packages or imports that we can use. And you can see here within the claim. And then we have another one. So if you basically import claim, you can then see the actual functions that we have access to. So from what we have currently available to us now is the claim structure itself. So again, we know the C type and we know the claim content. So we know this is going to be first name and second name, so we can use this function called from C type and claim contents, and then we can just pass it the C type because we've already predefined it up here, and then we can set the contents itself. So again, this takes an object, so we can define this by just stating that this is going to be an object. It's going to have two fields. It's going to be first name and second name, and what we want inside this object is the defined information, right? And that happens to be the first and second name, which we defined within our state. So we can reuse that and we can define it here. So again, you can see, I might think like that. No, maybe don't do it here. No, okay. Okay, I know what I'm missing. And then we need to define the user. So the user, we already have passed the user information, and we can just set that because maybe I should console log it out so you can see that the user is the person that's currently logged in. It might complain that I haven't passed this yet. So if I do this, this is why the setup's important, that we can actually access the user and we can talk to and communicate with the application. So here's the user. You can see this is defined in this use hook. Again, I won't talk too much about this, but what we're getting back is a DID identifier. You can see at the bottom of my screen, it's very tiny. Maybe I can also make this bigger. Yeah, you can see here, I have this. So if I define Dudley, and this is Needham, and then you can see this is my identifier or DID as well attached from this user. So we can reuse this and provide that as a stepping stone. Okay. Okay, so now that you have a claim, we can actually look at what the claim is going to produce. So again, claim, console logging this out. This is my claim. So what we want to do is essentially create a button. Okay, so now obviously we can't click it, so we need a button. So we've had this data entry. Now we want a button to suggest what we can do with it. So if we do button, I do capital B because this uses buttons. So again, I will basically create this button, and I will call this. Well, I just call this send data. Nothing special. And then what we want to do is we want to wait for a response on click. And so again, it's super easy to just do this for React. You just do on click, and then we already have a defined function here called on handle data. So again, it's just going to handle the data that's currently in there. So if I save this, a little button, that's why I like having it. And look, if I press the button, this works. It says, this is my claim. I have a C type, and that's the contents. And you can see this is the structure it will look like at the end of it. I can't really, if I make it smaller, you can see it. It's just a little object with these variables and stuff like that. So this is a claim itself, but we want to take that claim and create a credential from it. So again, this will provide the underlying structure. So again, for the attester to work with. So again, you can create credential here. And again, we're using the KILT SDK to create the credentials. Again, it's underneath import credentials dot, and then from claim. It's the function that we're looking for. So we can just do this and just pass the claim. And then we actually should console log this out, and we get hold of this is my credential. Oh, if I can spell. I know we're running out of time, and I haven't even gotten to the point of where I wanted to get to. So unfortunately, it's just too ambitious, but at least you can see where this is going a little bit, and you can maybe have a look a little bit later on the demo. But yeah, you can see it here. This is the credential itself. You can see the credential object, and we can create this root hash. This root hash is will be later used by an individual for the attester. How long? I've got 7 minutes. Okay. Okay, actually, this is going to the secondary point, which is the actual backend logic. So what we can do is we can define in the Pages API, which will allow us to access the backend logic to be able to provide information. Oh, Connor, capital B is only for styled components. That's just part of this project. It's it could have been a small b as well. You can use a small b, and if I did use a small b, it would just not have the texture of this button. So it would look like this. But that's the only reason why, because we have a bunch of components that we created for this project to make it look prettier. It's only to make it look prettier. I'll leave it like this for now, so not to confuse anyone. Yeah, so for the API, I just want to call this probably attester TS. Maybe not. We can call this attestation because this is actually where the logic of the attestation could live. Again, generally we want to have some form, again, some structure for this. We can reuse things. I think it's totally fine to reuse little parts of the project. I'm lagging a bit. I can see on my own screen. So I'm just going to steal the secrets page to provide just some sort of structure with it. It's already predefined here. You know, whenever someone sends something for the attestation, it will fire back here, and that would be it will fire back here just so that we know that it's happening. Again, we can just see what we can do with this credential itself. Yeah, I have time. So again, what we want to do is just check to see if this works. So I'm going to go back to Claimer. And when we do Claimer, we want to just create a fetch, basically, to see if it even works. So again, I'm going to access the API here. And that's only done by getting a fetch and then saying API and then giving the name that we just defined, so attestation. And then we want to provide it with an object, and that object is going to be a method. That's going to be post method. Does it do anything? Okay, it is fetching. So again, I think if we look at the network, we'll see attestations here, and then we can look at that. Yeah, okay, so the button worked. That's great. We'd like to see. So we can say this is the result, whatever that's coming back from us. And now we want to define the body. So the body is going to just be a string. Again, if you know TypeScript and JavaScript, this is just the way we have to do it, unfortunately. So I'm stringifying this credential, so turning this credential into an object, now into a string, so we can pass it to the body. So again, I will console log out the result, and we can see what we get. So again, once we do this, let's see. So I can look at the console logs. I will define this as this is the result. Okay, so we get a response. We accessing where we need to access. That's great. Now, what can we do with this? Well, we can this is why I stole the secrets handler, is that it's already got part of the stuff that we want to prevent people from just sending random information to us. It's got the cookie, and then it's got the to see if there is a user available, and we can pretty much use this now. What we want from this is the result of what's being sent by the user, and that's their credential. So again, I'm just going to pass this because we're waiting for the response from the body. And then we can actually console log credential and see if we actually received the credential from the backend. Again, send. Did I do something? Position 0. There should be a request. Yeah. Again, we can just, and this one's response. It makes it look nicer since we have the. So you can see here, we actually send it. You get my name, you get the CTAP hash, and you get the owner. And we can we could potentially start doing stuff with this now. And one of those things that we could do is we could just attest this. Again, this is not like the full demonstration I would have liked to have had. I think it was a little ambitious. I think we could have, I can spend a bit more time getting to this point, but the setup is also important because I think once you see that, you can start seeing where this is going to go. And what we can do now is we can actually look at the attestation. So again, we're going to verify that this is actually a way, an object that we want. So again, I'm going to import KILT from KILT SDK. And then we can just do await KILT dot credential dot verify credential. So we can have a look at this is to see if this object that we're receiving back is actually a credential. Is it complaining that there should be async? Again, we can see if this returns true or not. So we can log this out, console log, and see if it responds happily. It is undefined. Why is it undefined? It's a void. Yeah, so that's the response we want. There's no error thrown. Yeah, so basically, if you take this further, we would then start to go into like the attestation process. Since we're running out of time, I would have to wrap it up. And maybe just answer the last question. Unfortunately, I would have liked another 15, 20 minutes. Unfortunately, I just can't do this today. So yeah. Just going into Frank's question, can you give a brief example, maybe for healthcare? I'm a patient, I have some great health data. KILT would allow pasting reports, attestation reports, pasting. Yeah. So basically, you could do this very similar process here, where the claimer would have like this claim information, and then there would be some verification. So again, when we do a credential itself, you can do like a const create presentation of this. So you can take this KILT dot credential object. Let's create presentation, and then we can take this credential. We can pass it other attributes, and then at the end of it, we can. It has another, like you can see here. It takes a credential, signed callback, and selected attributes. So here's the one that we would want. So we can just say selected attributes, and then we can disclose that this it should be. Let me check. It should be an object. Okay, it's a set of string. So again, it needs to be like first name is one of, and then the second one could be second name, and so forth. And you can define the attributes that you want to showcase. And then with a bit more time, I would be able to provide this credential presentation with only the selected attributes. You may choose not to have any of them. And the way the hashing and mapping works is it allows you to selectively disclose them without actually revealing them. And then the verification function, like verify credential and then verification, you can prove that you own this claim. So for example, if you had some medical, I don't know, I'm going to use the word disease because I'm not very understanding of the what it might be, but for example, you have a disease or condition, yeah, you have a specific condition. You might want to state that you have a specific condition, but you don't want to reveal your first name and last name. And that could be one, yeah. No, but you can definitely define C type that is relating to health. That's completely doable. So yeah. Again, just talking about this itself, like this, from properties, you know, you could either call this like health data, and then you can, I don't know, you can even leave first name, second name, and then you can have some, I don't know, condition, and maybe it's like again type string, right? And then you would have to then define this within this set. So you might have something like condition, I don't know, a condition, just call it condition for now, because I'm not very creative with medical names or conditions and stuff like that. And you can define that. And I think with the challenge that we set, I think this would be a great use case on top of that challenge. You know, you could provide people attestations on medical conditions or medical care and so forth, and then provide attestations with that. But yeah. All right. Sorry for not getting to the main part of it. I apologize. It was a little ambitious, but again, if I go to the GitHub repositories, so I do have the repositories here. So you can go to our main repository called KILT Protocol. Bear with me again. I put the link in the description into the presentation, and you can find the branch here called Polkadot Hackathon. And then you can just check out the commit and see how this could have looked like. Again, I would have had the attestation, which allows you to do certain things and so forth. Again, I would highly recommend if you want to take it further. It should help out with the challenge itself, and you can see the general potential flow here, and maybe taking what we've done here, and then maybe start integrating or having a look at that and so forth. Alright, guys. So thank you for joining, and sorry for taking up a bit more than for your time. 5 minutes over. So thank you, guys, and yeah, bye everyone.